Okay, guys, so funny story. I'm trying to do the video. I hope this isn't a sign of things to come, but my very first video of the year, I went to load it up. I filmed it the first week of August, and I went to load it, and when I went to load it, parts of it didn't come out. And I did this for all of my classes last spring, so I hope that's not a sign of things to come. So I have to film part of this from my home office. Much cooler here, let me tell you that. Much cooler here, and I'm not wearing a mask, 'cause it's just me. So I got a couple pieces here. You'll kind of see it. It'll be embedded in the middle of the video because, like I said, it didn't come out. So we're looking at these mosaic plots, and this is the Python eggs part that I had you guys do. And if you haven't done this, please pause your video and try them. That's the way you're gonna get better at this stuff, guys, by pausing videos, by trying stuff, going back and watching it again. If you just sit there and go through the motions, do yourself a favor, do me a favor, take a different class. Honest to God. Okay, so it says Python eggs. Terrifying. Terrifying Python eggs. Are you kidding me? How is the hatching of water python eggs, I didn't know they were water pythons, influenced by the temperature of the snake's nest? Researchers randomly assigned newly laid eggs to one of 3 water temperatures, hot, neutral, or cold. Hot duplicates the extra warmth provided by the mother python, and cold duplicates the absence of the mother. The two-way table summarized the data. So here's your two-way table. Okay, remember, margin is on the outside, conditional is rows and columns on the inside, and the video that I'm going to put right after this is going to talk more about that. So it says, of the eggs that hatched. So they're asking you to look at, they're giving you a condition, okay? So it's a conditional probability of the eggs that hatched. So that means in this two-way table, we are only looking here at the eggs that hatched, okay? So it says of the eggs that hatched, of the numbers in this row, what proportion were assigned to hot water? Well, here's hot, here's how many hatched. So we're gonna say that part A, okay, is gonna be 75 out of 129. Now, this is really what they wanna see. They wanna see fractions more than decimals, but I think it's good to put both, okay? And then you do 75 divided by 129, and let me see if I can get my calculator out. The calculator tells me that that's going to be 0.581. And you're going to say, well, how many decimal places do I do, Mr. O? 3's good. 3's a good rule of thumb, okay? So that's part A. Part B, they're giving you another condition, okay? Of the eggs that were randomly assigned to hot water. So we're only looking at the ones in hot water. Here's hot water. In this case, that's a column. Of the ones that were randomly assigned to hot water, what percent hatched? So here's the hot water. So it's 75 out of 104. So part B is 75 divided by 104. And that would be 0.721. Okay, and I guess they said percent. Here they said percent. So we could make that 72.1%. Okay? So for part C, the mosaic plot displays the distribution of hatching status by water temperature. Describe what this graph reveals about the association, the relationship, between these two variables for the python eggs in this experiment. So we want to see if there's a relationship or not between water temperature and whether they hatched. So if we look, and we look at, let's say, cold water, okay, cold water, and hatched is yes, okay? So here's your cold water, and here's the amount that hatched. Here's the amount that didn't hatch, and so on, okay? So they were least likely. Look at both of these are higher than this one, okay? This percentage for hot, okay, I don't know what that's going to be, but it looks like it's going to be almost 70. This one's probably 65. This one looks like it's 58. So if we're talking about the cold, okay, the cold was about 59%, and the hot water we said was a little bit over 70. We'll say that's going to be 72%. Now, this is not an answer. In the statistics world, they will not give you credit for that, okay? We have to explain it. So we would say something like, the python eggs, so I'll write this out, the python eggs were least likely to hatch. Well, where are they least likely to hatch? They're least likely to hatch in cold water. So least likely to hatch in cold water. Now, I think it's good to have the percentage embedded in this. So we would say about 59%. And were most likely to hatch in hot water. Okay, and then we could put that percentage in as well. We said that was, that's 70, maybe a little bit more than 70, approximately 72%. Okay? So what can we say then? So we could say something like, the chance of hatching increases as the water temp increases. Okay? So this is what they're looking for in statistics. Okay? They are looking for explanations. They're looking for you to use what's called context. Context means you just don't say there's a relationship between, you have to go in and put in context. What's the relationship between hatching cold water, hatching hot water? That's context, okay? Not just saying it increases. As one increases, the other increases. You're gonna get nothing for that, okay? You wanna say what it is. What's the values of the variables, and put that into the context, okay? So that finishes up the mosaic plots, okay? I'm gonna pause the video quickly just so I can move this around and I can zoom in my camera, because I'm only gonna have one piece of paper to make it easier for you guys to see. And I'm gonna get in depth, really in depth, with marginal and conditional distributions. Remember, in this one we were talking about a conditional distribution, okay? Because we were looking at a row, we were looking at a column. Marginal distributions is working on the outside, working in the margins. Okay, I'll be right back.